If a ball is thrown into the air with a velocity of 42 feet per second, its height in feet after t seconds is given by y equals 42 minus 16t squared. Find the velocity when t equals 1. We know that we can use limits to figure out the instantaneous velocity. We want the velocity at time 1, and so this is going to be the limit as t approaches 1 of the difference in position functions, so that'll be y at time t minus y at time 1 over t minus 1. And we have to plug in those heights, those position functions at those values, and then simplify things and evaluate the limit. So we still have the limit as t approaches 1. Now y of t is just going to be 42t minus 16t squared. And then we have to subtract from that y of 1. I'm going to put parentheses here because we've got to subtract that whole thing. When t is 1, that's going to be 42 times 1 is 42, minus 16 times 1 squared is just 16. And then this is all over t minus 1. Great. Now 42 minus 16 is going to be 26. So we're going to end up being able to simplify that. Also, I think we can factor 2 out of each of those terms in the numerator. So we've got the limit as t approaches 1 of, if we factor out a 2, that is going to be, also we can move things around. That'll, let's factor out a negative 2, because then that'll give us a positive leading coefficient. Sorry, I'm thinking about the algebra here on the fly. If we factor out a negative 2 and rearrange the terms, that's going to give us our 8t squared. And then the linear term is going to be minus 21t. And then that constant term, it was negative, but we factored out a negative, so it's going to end up being plus 13, because we factored out the negative 2 all over t minus 1. Now, we are hoping to factor that numerator so that potentially we can cancel out that denominator, simplifying things and allowing us to evaluate this limit just by direct substitution. Now, the only way that's going to work nicely is if there's a factor of t minus 1 in the numerator. So we could just start from scratch and use the AC method, but I'm going to take a guess here. If we expect or hope that t minus 1 is a factor, t needs to get multiplied by 8t to become 8t squared. And then negative 1 has to get multiplied by negative 13 to get positive 13. I'm thinking about how we could FOIL to get 8t squared and positive 13. If we were to look at the outer and inner terms, we've got negative 13t minus 8t, which is negative 21t. So this problem was built for that t minus 1 to be factored. If you don't notice that, you can, of course, use the AC method. You can go through and factor all of that out. But I want to save a little bit of a moment here so this video doesn't get too long. You can do that on your own if you really want to. But now that we have factored it, we can cancel out those factors of t minus 1 in the numerator and denominator. And we're actually left not with a fraction at all. So I haven't used the eraser in a while. I can use that. And then we've just got negative 2 times 8t minus 13. And we can use direct substitution here. When we plug in t equals 1, that's going to give us negative 2 times 8 minus 13. 8 minus 13 is going to be negative 5, and negative 2 times negative 5 is positive 10. And we are dealing with feet per second. So the velocity after 1 second is positive 10 feet per second, so it is still going upward from that original toss after 1 second.